But I'm joining from Aksha International School.
Okay, okay. All right. So, Shreyan, you're joining us for the very first time, or you have joined us before also?
I have joined this before.
Before also. Okay. So, do you want me to give you a quick recapitulation of the dashboard, or you want us to begin with the demo because as you are the only one child, right? So we'll give you the gist of the teaching because I'll make you introduce with your mentor first, okay? Your mentor name is Mr. Tariq. That is a wonderful mentor. His classes are very, very knowledgeable and he's very strict towards teaching. So I hope you'll be going to get the best, of course, right? So you can interact and then I think we can begin with the demo then if you are aware of dashboard and everything, right?
Yes, ma'am.
Is it okay, Tariq? We can have a short demo with him.
Yeah.
Yeah, sorry. You got muted, sir. Just a
Yeah.
moment.
Yeah, we
Yeah,
can start. Hi,
right?
Shyam.
Yeah, okay.
So you are in grade 9, right?
Yes, sir.
What have you learned in your school so far?
So far we haven't started any topic yet.
Okay, so which board you are pursuing?
CBSE.
CBSE or CBSE? Good. Okay. So see, in fact, what is the plan of our course? We always start from the basics. First of all, we cover the basic questions so that the student can do good in the school examination. And then gradually we enhance the level and then take it up to level 1 and level 2, right?
Okay.
So in fact, in class 9, many things you are going to learn of class 10th also, right?
Okay.
Because this is the platform for Olympiad examination, right? So in Olympiad, some questions are asked of advanced level, which are in class 10. So we also teach that in the class, right? So let's start the topic. In fact, in your class this year, you have to learn about irrational numbers.
Okay.
And in class 8, you may have learned rational numbers,
Yes, sir.
right? So do you have any idea about rational numbers?
Yes, sir.
Can you tell me what are the rational numbers?
Ration numbers are the numbers which have no
Which are in
decimal.
the form,
Which
which
are
are
in
in
the
the
form of
form P by Q,
P by
which are
Q,
in the form P by Q, where Q
where
is
Q
not
is not
equal
equal
to
to
0.
0.
Okay, do you know why that condition is there? Q should not equal to 0. Any idea?
Because
Yeah.
if Q is equal to 0, it wouldn't be like, I don't know the exact meanings. Like,
Okay, so let me explain that first, okay?
okay, sir.
So I am starting with rational numbers, which was in the topic of class 8th, right? The numbers of the form P by Q, where Q is not equal to 0, are called rational numbers. This is the definition of rational numbers. Rational numbers are generally denoted by capital Q. In higher classes, for rational numbers, we use the capital letter Q.
Okay.
Now, for example, 5 by 2. This is the example of rational number. Minus 2 by 3. This is also the example of rational number.
Yes.
My question is whether 0 is a rational or not.
Uh, is 0 rational?
Yes or not? What do you want to say?
I think it's irrational.
Yeah, it's rational because we can write 0 by 1. By writing that,
yes.
it is of the form P by Q.
Okay. Yes.
So it is rational. So 1 is also rational because it can be written, right?
Yes, sir.
Minus 1, minus 2, right?
Yes,
All
sir.
are the examples of rational numbers. Fine?
Yes, sir.
What about 1.2? Is it rational?
1.2 is not rational.
No. Any number of the form P by Q. This can be written as 12 by
Okay.
10.
Yes, sir. 12 by 10. Okay.
So this is also rational number. Any number which can be written in the form P by Q is the example of rational number.
Okay. Yes.
right?
Yeah. Yes.
Got it?
Yes, sir.
Okay. Okay. And it is denoted by Q.
Hmm.
Now, the next thing I'm going to tell, which you don't have the idea, that rational numbers are divided into two parts. Uh, Let me rub it. Rational numbers can be divided into two parts. One is terminating decimal,
Ah.
and other is non-terminating decimal.
Ah. So is non-terminating decimal also called as recurring?
Yeah, recurring.
Ah.
That is the meaning of recurring.
Ah.
Terminating decimal, suppose 2.5, 5.12, or these are the examples of terminating decimal. But suppose 1.2 bar,
Yes.
right?
Yeah.
Or 2.333 dash dash dash. So this is the example of non-terminating decimal, right? So rational numbers are basically divided
Non-term.
into two categories,
Okay.
terminating and
Yes.
non-terminating. Now, which are the terminating decimals? See, we have to understand this because questions are asked based on it. Rational numbers will always be of the form P by Q.
P by Q.
Now, if Q contains factor of 2 only, factor of 2,
Ah.
2 may be 2 times, 3 times, 10
Yeah.
times, n times, so power of 2, then it is a terminating decimal.
Yes, sir.
If Q contains power of 5 only,
Hmm.
in that case also it is example of terminating decimal.
Decimal.
If it contains 2 and 5 both, in that case also it is example of terminating decimal. But if it contains any other number beside 2 and 5, then it is a non-terminating decimal.
Oh, okay.
See by example, suppose I am writing 7 by 2.
Hmm.
So it contains only 2.
2.
See, when we divide, we can write 3.5. It terminates.
Yes, sir.
Rule says if denominator contains only factor of 2, then it is terminating decimal.
Yes, sir.
Suppose 7 by 4. 7 by 4 is 7 and 2 square.
Yes, sir.
Again, it contains power factor of 2.
Hmm.
So again, this is terminating decimal.
Yes, sir.
If we divide, we can get 1.75. See, it terminates. Suppose 11 by 5.
11 by 5.
Rule says if denominator contains 5 only, it is example of terminating decimal.
Hmm.
We can divide 2.2. See, this terminates. Right?
Yes, sir.
Now, 11 by 25. 11 by 5 square, which is 0.44.
Okay.
See, it says that if denominator contains only power of 5,
5.
it is terminating
Terminating
decimal.
decimal.
Suppose 13 by 10. 10
2
can
into
be
5.
written as 2
2
into
into
5.
5.
Both are there.
Yes, sir.
Rule says if both are there, again it is terminating decimal.
Hmm.
We can
1.3.
divide and 1.3. See, it terminates.
Hmm.
Suppose 17 by 1000. So this is, right, 17 by 2 to the power 3 into 5 to the power 3. It contains both 2 and 5.
Yeah.
So if we divide, we get 0.17.
Okay.
Understanding these 3 points?
Yes, sir.
If denominator contains only 2 or power of 2, then it is example of terminating decimal. Only
Yeah.
power of 5, terminating decimal,
Decimal.
both. In that case also terminating decimal. But if denominator contain any other number except 2 and 5, beside 2 and 5, suppose 11 by 3.
7 by 3.
Now you will get recurring.
Yes, sir.
So it is non-terminating
By 6.
decimal example.
Okay.
Suppose you 9 by 7. 7, 20. 7 2 ja 14. 7 8 ja 56. 7 5 ja 35. 7 7 ja 49. And it will go on.
Yeah.
See, other than 2 and 5, so it is non-terminating decimal. Even 7 by 2 into 3. See, 2 is there.
Yeah,
but 3 is also there.
Yes, sir.
So if any
So
other number is there beside 2 and 3, it will be non-terminating.
non-terminating.
Got it?
Yes, sir.
11 by 2 into 5 into 7. This is
Non-terminating.
again the example of non-terminating decimal.
Terminating.
Getting?
Yes, sir.
So what I explained, rational numbers are divided into two categories: terminating decimal and non-terminating decimal.
Non-terminating decimal.
Rule says we do not need to divide to check by just looking at the denominator and its factor. If denominator contains power of 2 or power of 5 or both, in all these three cases, it is terminating decimal.
Yes, sir.
But if there is any other number except 2 and 5, then it is the example of non-terminating decimal.
Okay, sir. Clear.
Now, tell me, 19 by 15, terminating or non-terminating?
Terminating.
Focus at the denominator.
Yes, sir.
15 can be written as 3 into 5.
Oh, okay. Right. Sorry. Yes.
So, this is
Non-terminating.
non-terminating. Non-terminating. 21 by 50.
52. This is terminating.
This is terminating, right?
Yes,
17 by 36.
36. Terminating.
Factor of 36. 2, 2, 3, 3.
Acha.
See, 3 is there.
Okay.
So it is non-terminating.
Non-terminating.
37 by 56.
56. Terminating.
No, 56 can be written as 7 into 8. 8 can be 2 into 2 into 2. So 7 is
7
there.
is 2. Okay.
So it's again non-terminating. Right?
Yes, sir.
Twenty-three upon 42.
Non-terminating.
Non-terminating, right?
Yes, sir.
Okay. Now 63 upon 28.
Non-terminating.
How?
28, right? It's non-terminating.
How?
28.
How you come to know that it's non-terminating?
1 minute. Okay, wait. 4. Okay. It has 7, right, sir? When I'm a prime
It has
factor.
7.
Yes,
Okay.
sir.
You are writing this 2 to 7, right?
Yes, sir.
Now see, this is one of the important question asked in the Olympiad paper.
Okay.
See, right now 63 is also multiple of 7.
Okay, so I have to
Yeah, it is not in the least term.
least form.
So first
Okay.
of all, if it is cancelled, we have to cancel that. After
Okay.
cancelling, it is 9 by 4,
Which is terminating.
which is terminating. So we have, this is a question asked in Olympiad paper, this kind of question.
Okay, sir.
Although it looks that it is non-terminating, but after cancellation it changed and it becomes terminating.
Yes, sir.
Okay.
Sir, do you know Ishan?
130. Yeah, I know Ishan.
Okay, sir. I'm Ishan's
So,
brother.
oh, good. How is he now?
He's good.
I think he completed 12.
He completed 10th, sir.
Okay, he completed 10th.
Yeah, he got
So,
96%.
oh, wow, lovely, good, good. Okay, so I am also not new to you. Have you seen my earlier classes when Ishan
Yes,
was
sir.
checking the classes?
Yes, sir.
Okay, okay, good. So 11 7 ja,
Sir,
11 12 ja.
12.
So this is 12 by 7,
Just non-terminating.
non-terminating. What is his marks in maths especially?
Maths, he got 71, sir.
Okay, okay. It is bit less
Yes.
in math. Okay, no problem. So now you learn that rational numbers are of the P by Q form. Rational numbers are divided into two parts, two categories, terminating and non-terminating. If denominator contains power of 2, it's terminating, power of 5, terminating, both,
2
terminating.
and 5.
Any other number beside 2 and 5, it's
Non-terminating.
non-terminating. Right?
Yes, sir.
Okay. Now, this you have learned in class 8, right?
Yes,
Rational
sir.
number. Now coming to the topic which we have to learn in class 9, which is irrational number. Irrational number. The definition of, have you heard about this? Irrational
Yes, sir.
number?
Yes, sir.
Any idea what are irrational numbers? Definition?
I don't know the definition of irrational numbers.
Okay, so let me explain that. The numbers which are non-terminating
Okay.
and non-repeating
Okay.
called irrational numbers.
Okay.
This is the definition for irrational number.
Okay.
A number must satisfy both the conditions simultaneously.
Okay.
Failing in any one, the number is not irrational. I am again repeating. The number must satisfy both the conditions simultaneously. If number fulfill one but fail in other, then that number is not irrational.
Okay.
Now see the example and you tell me. Just focus on these two conditions.
Okay, sir.
And then check on these two conditions and then tell me whether these are irrational or not. My question is, the numbers which I am going to write are irrational or not?
Okay, sir.
Right? Now, 1.2.
1.2 is not irrational.
Okay. How you come to know that it is not irrational?
Because it's a terminating decimal.
Correct. It fails here. It terminates. But for a number to call irrational, it must be Non-terminating.
Not terminating.
So it fails in the first condition. So this is not an irrational number. Okay. 0.00001.
This
Is
is
it
also
irrational?
this is not irrational.
Not irrational because it terminates. First
It
condition fails. So no, it is not an irrational. Right?
Yes, sir.
1.777 dash dash dash.
This is irrational number.
No, check on two conditions are there. Check on that condition first.
Okay, it's not irrational because it's a repeating decimal.
Correct. Although it is fulfilling the first condition.
Okay.
It is non-terminating. But it fails in the second one. Because it is repeating itself.
Yes.
So since it fails in the second condition, again this is not an irrational number.
Okay.
5.7 bars.
This is not irrational.
Why?
Because it's repeating.
Yeah, although it is non-terminating, but since it is repeating, that's why it is not an irrational number. 2.22231 dash dash dash.
This is irrational number.
Right. The first condition, it is non-terminating.
But it's not repeating as well.
Not repeating, correct? So that's why this is irrational.
Irrational.
Correct? Now, 0.123 dash dash dash.
This is also irrational.
This is also irrational, right?
Yes, sir.
Now, a square root of right?
Non-perfect squares.
Non-perfect, yeah. Non-perfect natural numbers
are all irrational.
Are irrational numbers. Like root 2, root 3, minus root 5, 2 root 7, and so on. All these are example of irrational. But perfect square number is 1. So root 1 is 1. It's not irrational. Root 4, it's 2. It's not irrational. That's why it is saying of perfect natural number. Right?
Yes, sir.
The number must not be perfect square numbers. Fine?
Yes, sir.
Arnavi, please turn on the camera if you are there. See, it's the demo class, and in the class itself, it is one of the mandatory rule to keep the camera on. Then you can learn better. And I believe in interaction, right? So don't shy. This is your class. So you must turn on the camera. Then you can understand better. Okay. Now, one question is, write two irrational numbers between 2.12 dash 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 and 2.13 dash dash dash. Or leave this 2.12 and 2.13, or to take 2.17.
Okay, sir. Two irrational numbers.
Yeah, two irrational numbers.
2.121.
2.121, and then you have to put dash dash dash. If you are not showing dash dash dash, so you are writing, yeah, okay. It terminates.
2.134 dash.
134 dash dash dash, like this. These are the two examples, right?
Yes, sir.
Next one, write two irrational numbers between 2 and 3.
2 and 3, okay. Uh, 2.38 dash dash dash.
2.37 dash dash dash.
2.85 dash dash.
2.8. Better keep odd number at the end.
Odd number.
Yeah, it is better to keep odd number at the end,
Okay, sir.
right? 2.8183. Don't write 5 because most of the time it is a number is divided. When it is divided, it comes
Okay,
5 is
yes,
there,
sir.
right?
Okay.
That's why don't write.
Okay, sir.
Fine.
Hmm.
Okay. Now, this is the property.
Hmm.
Sum of rational and irrational is always an irrational number. If you add an irrational to a rational number,
Hmm.
it will be an irrational
Rational
again.
number.
Like 2 plus root 3,
Because
5
it's
plus
all
root
because
7,
it's yeah.
right?
Yes.
Difference of rational and irrational is always an irrational number. Same, 2 minus root 3, 5 minus root 7. These are also the examples of irrational, right?
Yes.
Product of rational and irrational may not be necessarily irrational. This is the main important point we have to understand.
Okay, sir.
See, if we are multiplying a rational with irrational, that always not necessarily give us irrational.
Okay.
It may be rational also. So we can't say that it is true always.
Hmm.
For example, if we multiply 2 with root 3, we get 2 root 3. Rational, irrational, we are getting here irrational.
Okay, yeah. Yes, sir.
Right?
Hmm.
Minus 5 into root 2. Rational, irrational. It is minus 5 root 2. Irrational.
Yes.
Right?
Hmm. Yes, sir.
So can you give me one, because I have written that it is not necessarily irrational.
Rational.
Can you give me one example where it fails, where we are not getting irrational, when we are multiplying a rational with irrational? This is one of the important question to be asked in Olympiad paper.
Okay. So it should be a not be a irrational number.
Yeah, it should not be irrational, where it fails.
Okay.
Arnavi, do you have idea? Can you give me an example
Sir, could you
where it
please
fails?
repeat?
See, I have written product of rational and irrational may not be necessarily irrational.
Yes, sir.
This sentence tells us that sometimes we may get rational also.
Example.
I have written 2 examples where we are getting irrational. So I am waiting for an example where when you are multiplying a rational with irrational, so we are getting rational in fact.
Root 2 into root 2 is 2.
See, no, we have to multiply rational and
Okay.
irrational. Root 2 both are irrational in fact.
So 0 into root
Yeah,
2
that is
is
the
0.
only example.
Okay.
If you multiply a number with 0 and 0 is rational, so this is the only example where it fails.
Okay. That's why it's not always okay.
Yeah, there is no other example except this. And that's why this question is asked in Olympiad paper. So a student must keep this in mind, that this is the example.
Okay.
That's why this sentence you will get in the Olympiad paper in a true false statement, whether it is true or false. Most of the students write that it is true statement. But since it fails here, so it is a false statement. Hmm. Now, product of two irrational numbers may not be necessarily irrational. May not be necessarily irrational. See, this is also a property. Now we are going to multiply two irrational.
Root 2 into root 2. 2.
Yeah, see, root 2 into root 3, we are getting root 6. Irrational, we are getting irrational.
Yes, student.
But if we are multiplying, suppose we have to multiply different numbers. So 2 root 2 into root 2, these are the two different numbers. Then we will get 4 and it is rational.
Yes, sir.
Any other example beside this type of example? Any other? Is there any mind in your mind? Any other example?
10 root 5 and root 5, 50.
It is similar to this. It is similar to this. I want other than this type of example. Two irrational, when you are multiplying, you are getting rational.
Root 3 into root 3 is
Same example, same type of example. Different type.
root 3
Focus
into
here.
root 3.
See, focus here. The first two, focus here.
Okay. 2 plus root 3 and 2 minus root 3.
Correct. 2 plus root 3 and 2 minus root 3. Both are irrational. But when we multiply, we get 2 square
Property.
minus root 3 square, which is 1. Okay, what are these called? What are these? Each other. What is, there is a special
Rationalizing
name.
factors.
Okay, good, rationalizing factor, but there is a, one particular name is given. These are called conjugates
Conjugates, yeah.
of each other. So conjugate of A plus B is A minus B, and conjugate of A minus B is A plus B. By changing the middle sign, we get the conjugate. Fine.
Yes, sir.
Okay. What do you understand by rationalization?
Making a number in the form of P upon Q.
Root 2 by root 3 is also in the P by Q form.
But Q is not equal. They should be integers. P and Q should be integers.
See, I'm writing the definition of rationalization. Rationalization is a process of removing irrational numbers
From the denominator.
generally in the denominator by rational numbers. If we remove irrational numbers and bring rational at irrational place, then that process is called rationalization. Here I have mentioned this in the bracket, and it says generally in the denominator. So here I want to point out, although we have to rationalize most of the time till class 10th in the denominator only, but we can do the same process in the numerator as well. 99.9% of the times we rationalize the denominator. But in higher studies, right, when we reach to 11 and 12, there onward, we have to rationalize numerator also. So don't think that rationalization is done in denominator only. This is a misconception among students, most of the students. They think that we can only rationalize the denominator. That is not the fact. That is not true. Yes, it is correct that 99.9% of the times we rationalize in class 9th and 10th denominator only. But we can sometimes rationalize numerator also. Right? Okay. How can we rationalize this one?
Root 3 root 3 multiplied
We,
with the
yeah, we have
numerator.
to remove this. We have to bring rational here, right? So just
So
focus here at the denominator. Whatever be the number written here, if it is one term, then multiply and divide by that. Doing so, we get root 6 in the numerator and 3 in the denominator. Now see, this irrational is removed by rational, which is 3. And rationalization is done. Minus 5 by 2 root 7. How can we rationalize this one?
multiplying root 7 in the numerator and the denominator.
Correct. Multiply and divide by root 7. We get minus 5 root 7. Root 7 into root 7, 7 into 2, 14. Now it is rationalized. Okay. Now tell me, how can we rationalize this? 1 by 2 minus root 2.
2 plus root 2 in the numerator and the denominator.
Yeah. If denominator contains irrational number with 2 terms, then to rationalize the denominator, the rule is we have to multiply and divide by its conjugate. The conjugate of this number is 2 plus root 2, 2 plus root 2. So we get 2 plus root 2, 2 square minus root 2 square. 2 plus root 2, 4 minus 2, 2 plus root 2 by 2. It is rationalized. Okay. 7 by root 11 minus 3. Rationalize and tell me the value.
7 bracket root 11 plus 3 upon 2.
Upon 2. If we multiply and divide by 7 plus root 3. 11, sorry. Root 11 plus 3. So here 7, root 11 plus 3, 11 minus 9. 7 root 11 plus 3 by 2. Okay. 3 plus root 2 by 3 minus root 2. Rationalize this one and tell me the value.
Should I tell right now?
You can do in the notebook, then you can tell me.
Done.
What is the answer?
11 plus 6 root 2 upon 7.
3 plus root 2, 3 plus root 2. We get 3 plus root 2 whole square. Here 9 minus 2. 9 plus 2 plus 6 root 2 by 7. So 11 plus 6 root 2 by 7. Shriyan getting?
Yes, sir.
Okay. 5 root 2 minus 2 root 5 upon 5 root 2 plus 2 root 5. Rationalize this one.
Done.
Hmm.
Hmm. 3 minus 2 root 10 upon 3.
Repeat.
3 minus 2 root 10 upon 3.
Upon 3.
Yes.
Here you are getting 3. See, 5 root 2 minus 2 root 5. 5 root 2 minus 2 root 5. 5 root 2 minus 2 root 5 whole square. 5 root 2 square and 2 root 5 square. This
7,
is,
sorry.
yeah, it would be 7. 50 plus 20 minus 20 root 10. And here 50 minus 20. So 70 minus 20 root 10 by 30. Taking 10 common. 7 minus 2 root 10 by 30. It cancels. So 7 minus 2 root 10 by 3. Right? Okay. Can you rationalize this one? 1 by root 2 plus root 3 plus root 5. Do you know how to rationalize when there are 3 terms in the denominator? Any idea? No? Same process is there. No difference. Only one thing we have to do. We know that the conjugate of A plus B is A minus B, or the conjugate of A minus B is A plus B, right? So what we have to do, we should take the first 2 terms as A and the last term as B. Then again it is of the form A plus B. Then we need to follow the same rule. Now, A root 2 plus root 3, it will remain same, only this sign will change. Root 2 plus root 3 minus root 5. Fine? Now, root 2 plus root 3 minus root 5. Here we can write root 2 plus root 3 whole square minus root 5 whole square. Getting? Now, root 2 plus root 3 minus root 5. This can be expanded using A plus B whole square. A square is 2, B square is 3, and 2AB, 2 root 6. And here minus 5. Now this 5 and this 5 cancelled. So we get root 2 plus root 3 minus root 5 by 2 root 6. Now tell me whether it is rationalized right now.
No.
Still irrational is there. Our purpose is to remove irrational and bring rational here. So it is still not rationalized. So now only one term is there. So multiply and divide by root 6. Here we get root 12, root 18, root 30, and here 12. This 12 can be written as 2 root 3. This is 3 root 2, and this is root 30 by 12. Now see, this is rationalized.
Yes.
Okay, one I am writing for you, do it. Root 5 minus root 6 plus root 11. which sign you have to change?
The last second sign, sir.
Only last one.
Yes, sir.
Keep this A. Only last one. Root 5 minus root 6 minus root 11.
Sir, I got an answer.
Okay, what are you getting?
I didn't simplify it more, but I was able to get it to root 150 minus root 180 minus root 330 by 5.
By 5.
Yes.
Okay, let me check. So this is root 5 minus root 6 minus root 11. Here it is root 5 minus root 6 whole square and minus root 11 whole square. Root 5 minus root 6 minus root 11. 5 plus 6 minus 2 root 30 and minus 11. 11
Okay.
cancelled.
That means
So
it will
root
be by
5 minus root 6 minus root 11 by minus 2 root 30. Multiplying by root 30. So here root 150, root 180, root 330, here by minus 60,
Acha, okay.
30 and 260. We can multiply minus sign in the numerator. These two will be positive. We can write root 330 plus root 180 minus root 150 by 60. Root 330, 180. This will be 5 common, so 5 root 6. 5 root 6. 180, right? 180. 6 root 5. 6 root 5. And then 155 root 6 by 60. Now see, it is rationalized. This question is important for Olympiad paper and not in this form. That is asked in a different form.
Okay.
So that we will learn. We have to do many questions in the class, many questions. Arnavi was not present in the beginning when I said, see how we will conduct the classes. Have you already taken classes at Olympiad Success earlier, Arnavi?
No, sir, I attended one demo in class 8th and you were only teaching that time.
Okay, there I was also. I was the taking the demo. Okay. So see, we have to start from the basics. We always start from the basics so that students can do good in the school examination. And then we gradually enhance the level to up to level 1 and level 2 level, right? Many things we are going to learn in standard 9 that would be of standard 10th also. Why? Because in Olympiad, many questions are asked in level 2 especially, which need concept of class 10th. So we are going to learn that also during the classes. So this will be the protocol of the class. And it was the demo. I show you just some of the basics and later we can learn more in the class. Anything in mind you can ask me. Nothing?
Yes, sir.
Okay, so I think enough for today. Right? Now, if you like, you can tell the team and you can join the class. Okay then, bye. Take care.
Yes, sir. Bye.